Hi, my name is Jasmine, and I am an experienced tutor, and I'll be helping you get through your Joint Admission and Matriculation Board examination questions. I hope you find my tutoring helpful. Okay, so question 1 has a a non-nary subtraction problem, and it looks like this. It says 1, 8, 6, 3, 0, 1, 6, 4, 1, 8, and they're both in base 9, and it just tells us to subtract. And at first when you see this it might seem a little bit confusing, but it's actually not that bad. The main difference is that we're used to, when we borrow or take, we would say we take in terms of 10, but this time we're taking in terms of 9, and you'll see how that comes into play. So you start off 0 minus 8. That's not possible. So we cross out the 3 and we put a 2. So far everything's pretty much the same. But instead of, normally we would say, well, now this is a 10 because 0 plus 10. But no, you do 0 plus 9. Okay, so now this 0 is a 9. 9 minus 8 is 1. 2 minus 1 is 1. 6 minus 4 is 2. 8 minus 6 is 2, and 1 minus 1 is nothing. And this is in base 9. So this is your answer. Plain and simple. Okay, question number 2 shows us a problem like this, and it wants us to find the value of x. So it says 55 base x plus 52 base x equals 77 base 10. So the way to solve this is you need to think of, first off, whatever your base is, remember that you use it to represent powers when numbers are listed. So for instance, 55 base x is going to be the same thing as saying 5 times x to the first power plus 5 times x to the 0 power. And 52 base x is 5 times x to the first power plus 5 times x to the 0 power, because this is the 0 and this is the 1 power, and then it would be 2 and 3 and so on. Right, so it's actually fairly simple once you know that. So you're going to set it up 5 times x to the 1 plus 5 times x to the 0 plus 5 times x to the 1 plus 2 times x to the 0 equals, and this is just 77 because it's 77 base 10. And then, so from here, what you're going to do is you're going to say, okay, so this is just 5x. We know that x to the 0, anything to the 0 is just 1. So 5 times 1 is 5. Okay, this is again 5x. And this is 2 times 1, so it's just 2, equals 77. Okay, so then we simplify. Here we have 2 common terms, so we're going to have 10x plus 7 equals 77. We're going to subtract 7, right? And then we're going to get 10x is equal to 70, so that x is equal to 7. And that's your answer. Question 3 shows this, and it wants us to simplify, and it gives us a series of fractions. So what you're going to do here is you're going to, you'll see I've underlined the fraction part of each number. So we're going to focus on just these fractions, and we're going to sort of separate the whole part from the fraction part, okay? So we're going to leave the 7 minus 4 plus 2, okay? And this is all representing one number here. And then, well, I don't want to make you think that this is multiplication or anything, because it's not. But essentially, this is one number, and then next to it we're going to have the fraction part of the number. So like here we have 4 and 3/4. This will be a number and a fraction. Alright, so we have 12, 4, and 2. We want a common denominator, and it looks like the best common denominator is going to be 12, because 4 and 2 go into 12. Okay, so to get 3/4, so that it'll have a common denominator with the number, with something over 12, we need to figure out 4 times what equals 12. Well, that's 3, which means we have to multiply by 3 over 3, so that we get 9/12. And remember, this is okay because 3 over 3 is equal to 1. So we're technically not changing the fraction, we're just changing it to a form that's usable for us. So now we're going to look at the 1/2. We're going to do the same thing. We're going to say 1/2 times what gives us a number over 12. Okay, well that's 6. So we multiply by 6 over 6, and we get 6/12. So now we have fractions that work with something over 12. So we can do this. We can say 1 minus 9 plus 6 over 12. Okay? So let's keep going. Let's simplify further. So 7 minus 4 plus 2 is 5. Okay? And then this part might seem a bit confusing because you'll say, well, 1 plus 6 is 7, and 7 minus 9 is -2, and then we have -2 over 12, and that's very confusing. That doesn't make any sense with what we've been working with. So actually what you have to do before you can go on and do that is you have to take from the 5. So here we are at, where are we? So here we have 7 minus 9, and we know it's not going to work out. So what we can do is we can sort of borrow from the 5. So what's going to end up happening is we're going to take so let me describe it this way. So if we're taking 1 away from the 5 and putting it into this fraction, and we're working in terms of 12, alright, 1 is equal to 12 over 12. Okay, so this, I'm going to simplify a little bit. We have 5 and -2 over 12. But we're going to take away 1 from 5, so it's going to be 4. And instead of -2, it's going to be -2 plus 12. Okay, this is that 1 that we just took away. Alright, so then this is 4 and 10 over 12. So now you can just simplify a little bit more. So this is 4 and 5 over 6, because 10 and 12 are both divisible by 2. And this is as far as you can simplify, so that's your answer, 4 and 5, 6. Okay, question 4 gives us a problem, and it has a fraction, but the fraction's been split up into addition problems, and it says to figure the answer out to 3 significant figures. Alright, and so you see right away by the options that you're probably going to get decimals, and it looks kind of scary, but we can do it. Alright, so we're going to start with the top. So we have 81.81 plus 99.44. Okay, I'm going to line them up this way so that it's easier to add. So 1 plus 4 is 5. 8 plus 4 is 12, so we're going to bring up the 1. 9 plus 2 is 11. We're going to bring up the 1. 17 plus 1 will give us 18. Okay, so that's the first part. So now let's do the bottom. So we have 20.09 and we have 36.16. We're going to add, just straight and simple, 9 plus 6 is 15. Bring up the 1, we have a 2. That's 6, and that's 5. So these two numbers that we're going to work with in division, so we're going to take 181.25 divided by 56.25. Okay, and when you're dividing, when you're going to do long division with decimals, the outside number cannot be a decimal. So we need to move this decimal place, this decimal 2 places over, and that means we're going to have to do the same thing to the inside number. So now the new problem, and I'm going to switch colors now. Okay, so the new problem is going to be 181. Oh, sorry, not 0.25. It's going to be 181, and then you're going to write the 25, and the decimal place is here now. So now it's 18,125, and we're going to be dividing by 5,625. All right, so hold on a moment. Okay. Alright, so we've gotten this far. So the next part is we're going to have to approximate how many times 5,625 can go into 18,125. And the best way to do that I can think of is just to round first and just give it a shot. So 5,625, we're going to round up and say that's pretty close to 6,000. We're going to say 18,125 is fairly close to 18,000. And it's fairly easy to see that a factor of 3 could work here. So we're going to try 3, and I'm putting it over the 5 because the 5 is in the ones place and working with a number that is only in the ones place. Alright, so we're going to do over here, we're going to do some scratch work. And I'm going to get this out of the way. So we're going to do 5,625 times 3. Okay, so 3 times 5 is 15. Bring up the 1, that's 6 and 7. 3 times 6 is 18. 8, bring up the 1. 3 times 5 is 15 plus 1 is 16. Okay, so we're going to do, now we're going to just subtract 16, 8, 7, 5. Okay, so we're going to get 0. We have to borrow. This becomes a 0. This becomes 12 minus 7 is 5. We have to borrow again. 10 minus 8 is 2. 7 minus 6 is 1. Okay, so 5,625 into 1,250. So some people here would be tempted to write a remainder 1250. But we can't do that because they want the answer to 3 significant figures. We can't just leave it there. We have to get a decimal answer. Okay, so the number that we had before all my scratch work got in the way here, I'll rewrite it. Okay, the number that we have here, 18,125 is the same thing if I just put another decimal point and a 0 there. This is still the same number. I can do that. So now I can bring down the 0, and now I have a bigger number to work with. 5,625 can go into 12,500. And this time, I mean, again, you can sort of do that approximating thing. This is close to 6,000, and this is fairly close to 12,000 or 13,000, so it can probably go in about 2 times. Okay, so we're going to put a decimal point above the other decimal point, and we're going to put a 2 here. Now we're going to do some scratch work again. We're going to get 5,625 times 2, and we're just going to multiply. 2 times 5 is 10. This is 4 plus 1 is 5. 2 times 6 is 12. And 2 times 5 is 10 plus 1 is 11. So now we have 11,250 to work with. We subtract. This is 0. We're going to have to borrow. This is 4. This is 10. That's 5. This is 4 minus 2 is 2. And 2 minus 1 is 1. So we're back at this 1,250. So we just figured out earlier that we had to put another 0, bring the 0 down, get this number again. We're going to do the process again. We're going to get a 2 here. And you do it again, you realize you get the same thing. So it's 3.22, and the 0.2 keeps repeating. Okay? So they only want the answer to 3 sig figs anyway. So this is really the part that you need, 3.22, and that's your answer. Question 5 says, it's a word problem, and it says a man bought a second-hand photocopying machine for $34,000. He serviced it at a cost of $2,000 and then sold it at a profit of 15%. What was the selling price? Alright, so first we need to look at this and say, alright, so he made a profit of 15%. What is he making that profit off of? If he's going to make a profit, he's going to make a profit of however much he spent on it. So he spent this much to buy it and this much to fix it up. So in total, he's already spent this much, the $34,000 plus the other $2,000. Okay, so he's spent $36,000, and then he's going to make a profit of 15% off of this. So to figure out that, we're going to say 36,000 times 0.15. Okay, and to make this a little bit simpler on ourselves, we're going to recognize that there's 3 zeros here, so we're going to put the 3 zeros down. And then on the side, we're just going to do 36 times 0.15. Or, sorry, we're going to do 36 times 15 on the side, and then we'll worry about the decimal last. Okay? So 5 times 6 is 30. 5 times 3 is 15, plus 3 is 18. Okay, so we put a 0 because we're moving on. This is 6. This is 3. We're going to add 0, 14, 1, 5. Okay, so we have 540. We just put that in front of our other zeros. Okay, there's 2 numbers behind the decimal place, so we have to go 1, 2. That's where our decimal place goes. So this is 5,400. Or, yes, 5,400. But this is not how much he sold it for. This is how much profit he made. So this is the 15% profit off of this. So now we have to add that. It's 3,600 plus 5,400. Okay, so this is 0, 0, 4, and 11, 1, and here we go. 41,400. Question 6 is another word problem, and it says a student spent 1/5 of his allowances on books, 1/3 of the remainder on food, and kept the rest for contingencies. What fraction was kept? Okay, so you need to think of what you're starting out with. You're starting out with a whole, you're starting out with 100% 1. Okay, so, and we're working in terms of 1/5. So we're going to change this over into 5 over 5, because 5 over 5 is the same thing as 1. Then we're going to subtract 1/5 and get 4/5. Okay? And then it says it spent 1/3 of the remainder on food. When it says of the, when you see the words of the, it means to multiply. Okay, 1/3 of something, this is the same as saying 4/5. 4/5 divided by 3. You would take the reciprocal of 3 and multiply. So this is, we're just going to get 4 over 15.
Total spent will be equal to amount spent on books plus amount spent on food. That will be 1/5 plus 4 over 15. This is equal to 3 plus 4 over 15, which is 7 over 15. Amount reserved for contingencies will be what is left over after total spending. This will be 1 minus total spending, which is equal to 1 minus 7 over 15, which is 8 over 15. So our answer will be 8 over 15.
Okay, question 7 shows us a problem like this, and it wants us to solve for x. And so what we're going to do first off is you realize this is fairly complicated, it looks like. You might want to distribute the 2 here and maybe try to go from there, but that's still not very helpful. So what you need to do is realize that this is a really good log problem. Okay? So what we're going to do is we're just going to take the log of everything, and then these exponents will be able to take them out, and this multiplier will be able to make into addition, and it'll all sort of solve itself. Okay? So we're going to figure out which log base would be the best for this problem, and I'm going to say 25 would, because that's 5 would work well with a perfect square like 25. Okay, because we know that 5 squared equals 25. Okay, that's going to come in handy later. Okay, and the 0.04 we'll actually see how that works out as well. So we're going to say the log base 25 of 5 to the 2 times x minus 1 times 5 to the x plus 1 is equal to the log base 25 of 0.04. Okay, so just using the rules of logs, we know that since these 2 are multiplied, we can split them apart into 2 added logs. Okay, so we're going to have log base 25 of 5 to the 2 x minus 1 plus log base 25 of 5 to the x plus 1 is equal to the log base 25 of 0.04. Okay, so again, using our rules of logarithms, these exponents, we can take them out and put them over here, okay? Because the log base b of m to the a can be simplified into the log base b to the m times a. Okay, the a can be pulled out and just put it over here. Alright, so 2 times x minus 1 times the log base 25 of 5 plus the log base, Okay, so we're going to pull out this exponent over here. So we're going to say plus x plus 1, the quantity, times log base 25 of 5 is equal to log base 25 of 0.04. Okay, so we're going to keep going. We're going to simplify it right here. So the log base 25 of 5. Okay, normally what we ask ourselves is, this to what power equals this? Okay, and so we know that the square root of 25 is 5, and we can express a square root in terms of a power. So we know that the square root of x is the same thing as saying x to the 1/2, right? So that means that the square root of 25 can be expressed as 25 to the 1/2 power. Okay, so that's what I'm going to say here. 25 to the 1/2 power equals 5. So the answer of log base 25 of 5 is 1/2. So we're going to do 2 times x minus 1 times 1/2 plus x plus 1 times 1/2 again equals log base 25 of 0.04. Okay, so this part, 25 to the what power equals 0.04. And this part, this part might seem a bit daunting. You look at it and you wonder, what on earth does 25 equal to a decimal? How am I supposed to even know that? Okay, here's the thing. Okay, so here's the 4. It's in the hundreds place, right? Tens, hundreds, 4 hundreds, hundredths, 4 hundredths. So I need you to think of this. So, but 1 over 25. 25 is 1/4 of 100. Okay? Okay. So 25 is 1/4 of 100, right? So what if I were converting this into, you know, how we express, I guess, decimals? Okay. So 25 times 4 is 100, and then 1 times 4 is 4. So here we are at the 4 hundredths. Okay, 1 over 25 is 4 hundredths. So that means that 25 to the -1 power, you know, which means this, is 400th. So the answer of log base 25 of 0.04 is 25 to the negative 1, which means negative 1 is the answer to log base 25 of 0.04. Okay, so there's this part, and then we're going to simplify things out over here. So this 2 and this 2 are going to cancel. I'm going to be left with x minus 1 plus, and then we're going to get 1/2 x plus 1/2. Okay, so we're going to continue simplifying, and so we're just going to say we're going to add the 1 here, and then subtract the 1/2. Okay, so let's see here. What are we left with? We have the x, and the 1/2 x is going to make 3/2 x is equal to negative 1/2. Okay, so we're almost there. And then we're going to say x is equal to negative 1/2 divided by 3/2, which is the same as saying negative 1/2 times 2/3. Okay, so we get negative 1/3. That equals x, alright? So there's our x, that's our answer. Okay, question 8 gives us, it lets us know that the log base 10 of 2 is this, and then the log base 10 of 7 is this, and it wants us to evaluate log base 10 of 280. Alright, so first it's important to take a look at what we're given, the 2 and the 7, okay, and the 280. So we want to know how many times the 2 and the 7 can go into 280 and see what else we can do with it. So 280, okay, let's focus on the 28, because the 0 is easily made up of a component of 100. Well, you'll see what I mean. Okay, so 7 times 4 is equal to 28, right? 4 can be made up of 2 times 2. So essentially we have 7 times 2 times 2 gives us the 28. Okay, and bear with me here. So then that makes up the first part here, but then also we need the 10. So the thing that I'm trying to show you here is that 28 times 10 is equal to 280. Okay, and then so 7. Oh, sorry. So then 7 times 2 times 2 times 10 equals 280. So we're going to use this right here. We can now say that you can have the log base 10 of 2 times the log base 10 of 2 times the log base 10 of 7 times the log base 10 of 10 will give us the log base 10 of 280. Okay, so we know what each one of these are, and we can figure out this one fairly simply. So the log base 10 of 10, okay, so 10 to the what power gives us 10? 1, okay? 10 to the 1 equals 10. So there's that part. These two other numbers were given to us. We have 0.301 times, I'm sorry, this is, I knew I was doing something wrong. We need to add these numbers. Add these numbers, okay? Because of the build-up blocks. So then 0.301 plus 0.8451, okay? And then again plus 1. And then that's going to give us our answer that we want, okay? So just going to add all of this. So first, I don't want to do it all in my head, but 0.301 plus 0.301 is the same as saying 0.301 times 2. It's pretty easy to see that it's going to be 0.602. Okay, and then we're going to say plus 0.8451. Okay, I'll put another 0 there so I don't get lost. And then we're going to add 1. Okay, so this is 1, 7, 4, 14, 1. Okay, and so we get 0.24471. And that would be our answer. Question 9 wants us to simplify, and it gives us one of these forms of where sometimes it's referred to as x plus root y, but what's important to note is that when you see a problem like this, you want to look at the denominator, and you want to figure out what you can multiply by to get the denominator into a whole number, and so that way you can work with a fraction that is that you are able to pull apart and simplify with easily. Okay, so we can multiply by 3 minus the root of 7, and you're going to see why this is favorable. Okay, so let's just work on the denominator right now. Okay, so I'll pick another color, do green. 3 plus the square root of 7 times 3 minus the square root of 7. Okay, so let's just go ahead and multiply these out. So this is 9. Okay, this is negative 3 root 7. This is positive 3 root 7. Okay, and this is negative 7. Right? Because the two square roots come multiplying, and then there's a negative. So yes, that's why that happens. This you can cancel. Okay, so you're left with 9 minus 7, and then you get 2. Okay, that's much simpler to work with than this, you know. So our denominator is going to be 2. Okay, so let's work on the numerator. Okay, and we'll do violet. Okay, so we're going to have 5 plus the square root of 7 times 3 minus the square root of 7, and I'll work it out for you again. So this right here is 15 minus 5 root 7 plus 3 root 7 minus 7. Okay, so we're going to have 15 minus 7 is 8, and then these like terms are going to simplify to negative 2 root 7. Okay, so we're going to have 8 minus 2 root 7 over 2. Okay, this is very nice. We can simplify here. So this 2 can go into this and to this. So this is the same as saying 4 minus the square root of 7. And there you go. That's your answer. Question 10 says if x is n squared plus 1, where n is a positive integer and is within the closed interval 1 and 5, and y equals 5n, where n is a positive integer and n is within the closed interval 1 and 5, find x intersection y. Now I want to note a few things. First off, this right here is labeled a little bit differently in the question. It's written like this. So what this is saying is n is in between 1 and 5, and it includes 1 and 5. Okay? So you write that on a number line, for instance. Here's the number 1, here's the number 5. 5 is included, 1 is included, everything in between is included, okay? Because n is greater than 1, but less than 5. Alright, and you can also write it this way. Brackets like these mean inclusive, and that's why I have this. If the brackets were written like this, it would be exclusive, and 1 and 5 would not count. But that's not the case here. Same thing down here, alright? X intersection y is written like this. Okay, there's two symbols, this and this. They are not the same thing whatsoever. The one that looks like a U means union. The other one is an intersection. Okay, the way that you tell the difference between the two of these is intersection is much more exclusive, whereas a union you have to include everything. Okay, so the way that I remember this is that in a union, for instance in a marriage, you have to bring everything from both sides, everything that one partner brings and the other partner brings becomes 1. So to speak, that's not always the case, but you know, that's ideal. And whereas intersection, that's not quite the case, it's much more exclusive. So, okay, here is union. You would include everything from both circles. Okay, where they cross over, where they don't. If it's in both circles, you're including it. Here's intersection. You only include the area where they intersect. Okay? So there's some examples to help you understand the differences there. Okay, so they want us to find where it is that there are points that are unique to both sets. Okay, so we're going to evaluate each of these at the points between 1 and 5 and just see where they match up. Okay, so we're going to do x first. And the rule for x is n squared plus 1. Okay, so we're going to try 1. 1 squared plus 1 is just 2. Okay, let's try the number 2 now. 2 squared is 4 plus 1 is 5. Let's try 3. 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. Then 5. 5 squared is 25 plus 1 is 26. Okay? So this is our set of numbers right here. That's for x. Okay, so now let's do y. The rule for y is 5n. Okay, and it does say that n has to be a positive integer, which is, I mean, we are using positive integers, so that's fine. Okay, so 5n. Again, we're just going to plug in. So if it were 1, it would be 5. Okay, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25. Okay, so this is the set for y. Now we want to find x intersection y, which is where are they the same. So they're the same, they have the same outputs 5, they have the same output 10, and that's pretty much all they have in common. Okay, so your answer would look like this. Okay, and that's your answer. That's your set, 5 and 10. Okay, so here we have question 11, and it is quite the mind teaser, but basically it's S intersection T intersection W equals S, and then S union T union W equals W, and T intersection W equals S. Okay, then it says if S is a subset of T is a subset of W, which of the above statements are true? Okay, so here's what we have to think about. First off, let me tell you what the notation is in the problem. Okay, it's written like this: S intersection T intersection W equals S. Okay, this is how it's written out. And then it says S union T union W equals W, and T intersection W equals S. Okay, I just wrote it out in words because I feel that in my handwriting the U's get confusing amongst all the U's and the intersections and unions symbols. They get confused amongst my other letters, and I didn't want to confuse you too much. Subset over here in the question, it says if S, and it has this sideways U, and it says T, and then it says another sideways U, or even like it looks almost like a C in my handwriting, and then it says which of the above statements is true. When it says that, when it shows this sideways U, okay, it's talking about a subset. Okay, that's what these mean. Okay, and I wrote it out in words for you so it could be easier to understand. So if S is a subset of T is a subset of W, what does it mean to be a subset? Okay, so here we have 1, 2, and 3, and then here we have another set, and it's 1, 2, 3, 4, 5, and 6. Okay, let's call this X and let's call this Y. I can tell you that X is a subset of Y because, you know, X has values that are found inside of Y. Alright, so a subset means that, you know, the subset has numbers that are found up here. All of the numbers in X are found in Y. That doesn't necessarily mean I mean, by definition, it means that x is not going to have some of the terms that are in y, okay? But that's what that means, okay? That's what subset is. Alright, so if they're telling you that S has elements that are in T and T has elements that are in W, that means that W is the overarching statement, okay? So in my opinion, what this out here makes it a little bit confusing, but what you need to understand, what they're saying here in 1 and 2 and 3, what they're saying out here is that W is like the universal holder of all of these, okay? Because it's true, they are intersections because they have intersections. How to explain this? So S has S has values that are, or elements that are found in T, and T has elements that are found in W. So if you work your way backwards, you'll find yourself at elements of S. Okay, so one is correct. All right, and 3 is also correct, and that's because you know, T is intersection of W, and you'll find elements of S there. Okay, this is not correct, and that's because of the union symbols. Okay, intersection means that it's going to have some values that are the same, that are unique to both sets. But union, I explained in an earlier problem, is more relaxed in terms of what is allowed. And so that would mean that everything in W is in S and everything in W is in T, and that's not true. W has more terms that are in S and T, most likely. We cannot say that they all have the same terms because we don't know that. So 2 is incorrect. Okay, so your answers should be 1 and 3. Okay, so here we have question 12, and it wants us to express R. I didn't write that in here, but it says to express R in terms of P, S, and T. Okay? So what we're going to do is basically solve for R. Alright, so we're going to work on isolating the variable R. So the first thing we need to do is get rid of the radical, and by what we're going to do that is squaring both sides. Okay? So this undoes the radical over here, and we're going to have P squared is equal to R times S cubed over T. Okay, your next step, let's get rid of the denominator over here. Let's move it to the other side by multiplying by T. Okay? So this cancels, and we're going to have P squared times T is equal to R times S to the third power. Okay, let's divide by S to the third power to isolate R even more, and we're left with P squared times T over S to the third power is equal to R, and that's your answer right here, this part. Okay, question 13 gives us, it says a polynomial in X whose roots are 4/3 and -3/5 is. And so the way you want to go about solving this is you want to realize that we're talking about a polynomial in X. So, you know, polynomials and roots. Okay, so we're going to have X minus 4/3 and X plus 3/5. Okay, and the reason why I used minus 4/3 and plus 3/5 is because when you're doing the math and you're solving for X to get the roots, you know, you'll have here X minus 4/3, and if you were to solve for X, you would say X minus 4/3 is equal to 0, X is equal to 4/3, and that would be your root. Okay, so that's how they got that. They started here, right? So that's just how the math works out. And then we're going to simply multiply this to get a polynomial. So here we have x squared plus 3/5 x minus 4/3 x minus 4/3 times 3/5, and we're just going to continue simplifying. Okay, so we're going to have x squared plus 3/5 x minus 4/3 x and minus, and we're going to multiply this and get 12 over 15. Okay, so let's keep going. We need to find a common denominator because these are like terms, but they don't have common denominators right now. So we're going to convert these to have a common denominator of 15. Okay, so x squared plus, to convert this, we would say times 3 over 3 would give us 9 over 15. Okay, so this is 9 over 15x minus, this part we would do 4 over 3, over 3 times 5 over 5 would give us 20 over 15. Okay, so here we have minus 20 over 15x minus 12/15. Okay, so let's keep going. We have x squared plus, this is going to be negative 11 over 15 minus 12/15. And then this might still seem fairly unfamiliar to you. It doesn't look like anything that you see in your answer options. It's a little confusing because of the fractions. What you can do is you can multiply all of this by the number 15. Okay? Everything by 15, and as long as you do it to everything, you're fine. So you're going to have 15x squared minus 11 minus 12. 11x, I forgot my x in there. Okay, 15x squared minus 11x minus 12. And that's the answer. Okay, question 14 gives us a graph, and it wants us to find the equation that most represents this graph. Okay, so I've highlighted points that are fairly obvious just from looking at the graph. So it tells you that it hits over here. This is the x-axis, this is the y-axis. So it hits the x-axis at 1/4, and again over here at -2. Okay, and it also gives us the y-intercept is positive 2. But it turns out you don't really need this. This is extraneous information. These two are fairly important. So these points where it hits the x-axis are the roots of the equation. And you should know that roots of the equation, you can find that, mathematically when you have a polynomial, which you can tell that this is a function that has a square in it, because it's not a straight line. It curves like this. So what we need to do is we're going to say that 1/4 and -2 are roots. So we're going to say x minus 1/4, because remember when you are doing the math, it starts off as x minus 1/4, and you're going to end up with x equals 1/4. And so over here we change the sign again, we get x plus 2. Okay? And then you're just going to multiply these out. So we're going to get x squared plus 2x minus 1/4 x plus, let's see here, minus, I'm going to do this over here, 2 over 1 times 1 over 4, and it's going to be negative. Okay, so we're going to get equals -2 over 4, which is -1/2. Okay, so minus 1/2. So let's keep going. We're going to get x squared minus, okay, so this time we have to do 2x minus 1/4. Okay, so I'm going to delete my little minus sign because I don't know. Okay, so 2 is technically the same thing as saying 8 over 4, right? And then minus 1/4 equals 7/4. Okay, so plus 7 over 4x and then plus, actually, oops, I'm going to change this, and see if I can, let me just use my eraser. Okay, and then we're going to say minus 1/2. Okay, if you want to get rid of the fraction so it's easier to look at, we're going to multiply by the biggest denominator so that it cancels, because lucky for us 2 goes into 4. Okay, so everything times 4. Alright, so we're going to get 4x squared plus 7x minus, and then we're going to do 1/2 times 4, which would give us 4/2, which is just 2. Okay, and so this is the equation of this. Okay, so question 15 says W is directly proportional to U. If W equals 5 when U equals 3, find U when W equals 27. Or sorry, 2 divided by 7. Alright, so what we want to do is start off with the first part. Okay, so it says W is directly proportional to U. What this means is that W is equal to some sort of constant times U. Okay, and I just chose K as my constant. Alright, directly proportional to means that they follow each other in the same way. So that means if W goes up, so should U. U should also go up, okay? And they're proportional, so they should go up by the same amount every time. Alrighty? So that's why we have a constant K here. Okay, so they tell us that when W is equal to 5, we still don't know K, but U is equal to 3. So we're just going to solve for K. So we're going to, K is equal to 5/3. Alright, so now we have this equation. W is equal to 5/3 U. Okay, and now we want to find U when W equals 2/7. Okay, so 2/7 is equal to 5/3 times U. Alright, so we're just going to divide by 5/3. And when we're doing fractions like this, 2/7 divided by 5/3 is the same as saying times 3/5. Okay, so we get 6. 2 times 3 is 6, and 7 times 5 is 35. Okay, and that equals U. And here's the answer. Question 6, determine the value for x where this is true. So the first thing to realize is that x squared minus 1 is actually the difference of squares. Okay, so we're going to have x plus 1 times x minus 1. Okay, and we want it for values where it's greater than 0. Okay, and so if I were to multiply this right here out, I would get this up here. That's how I know that I can do this. So we know that x can, if I had said that it were equal to 0, okay, I would know that x is equal to -1 or x is equal to +1. Okay, but we need it for values where it's going to be greater than 0. So sometimes it's helpful if you draw a number line, and here is -1 and +1, and you just go ahead and try to evaluate it at values outside of your range and inside of your range. Okay, so for instance, x values greater than -1 would, well, what would that yield? Okay, so let's just try it out up here. So, or what I'm saying is, it might be easier for us to use decimal numbers in this version than it is to square a decimal number and then subtract 1. So let's say I took -0.5. Okay, so -0.5 plus 1 times -0.5 minus 1. Okay, so -0.5 plus 1 is still, it's going to be 0.5. Okay, times what do we have here? Negative 0.5 minus 1 is going to be negative 1.5, right? So our answer is going to be negative. So it's less than 0, which is not what we want. We want x to be greater than 0. Okay, and that's not true at 0.5. It's not happening. Okay, so let's try. Sorry, at negative 0.5. Let's try it at 0.5. Okay, so 0.5 plus 1 times 0.5 minus 1. Okay. Oops, sorry. No, not this way. So we're going to try it again. So 1.5 times negative 0.5. Again, we get a negative number, right? So it's also not going to happen over here. So, you know, at values of x, x greater than negative 1 and less than 1, they're not going to work out. Okay, but if we try values greater than 1 or more negative than negative 1, we'll find that it does work. Okay, so let's try 1.5. Actually, let's try the number 2. Okay, so that's above 1, right? So 2 plus 1 times 2 minus 1. What happens? We get 3 times 1, and that's a positive number. Okay, and the same thing will happen if you do it for the negative, but I don't want to make this video run too long. So what you end up finding is that x has to be greater than 1, and x has to be less than negative 1. And you'll find that if you plug in 1 or negative 1, you're just going to get 0. Okay, so it's not including values, and that's, you know, you have this over here. It's not, we're not going to need the sign that says equal to. Okay, so it's just x greater than 1 and x less than negative 1. So for question 17, it says find the range of values of x for which, I'm going to write it out, 3x minus 7 is less than or equal to 0, and then over here it says x plus 5 is greater than 0. Okay, so what you're going to do is essentially first simplify things for yourself and just solve for x for both of these. Okay, so 3x minus 7 less than or equal to 0. Just isolate x. 3x is less than or equal to 7, right? And then x is less than or equal to 7/3. And we're going to do the same thing on this with this one. So x is greater than negative 5. Okay, so this is what you want. You want x values that are greater than negative 5, but less than or equal to 7/3. Okay, and that's your answer. Question 18 gives us an arithmetic sequence, and it looks like this, and then it wants to find out a good equation for solving for the sum of the first n terms of this sequence. Okay, so it's not asking for the rule of how to get this sequence, it's asking for the rule of how to get the sum of the numbers in this sequence. Okay, so your sums are going to be as follows. Obviously for the first term it's just 5, but then 5 plus 11 will give you 16. Okay, and then 16 plus 17 will give you, I don't want to do the mental math wrong, so 6 plus 7 is 13, and then we get 33. Okay, and so on and so forth. Alright, so it's tempting for some people when they're setting this up to think, well, I'm always going to be adding 5, so I should add 5 plus n and then work on the n or something and keep going. But actually, for the first term, you need to get 5. Okay, so that won't work, because then when n is I mean, what are you going to say? Are you going to say like 5n? If you said 5n is going to be your sum, it'll work for the first term, 1, right? If n equals 1, then you'll get 5. But then when n equals 2, you're going to get 10, and that's not what your next sum is. So this doesn't quite work, and Let's see if I can do this. Okay, so that's not going to work. Okay, so what you need to do is you sort of split it up. So we're going to say 3n plus 2, okay? And so this starts to get us there. But then once we keep going, well, again, we had the same problem. So this time we're going to have 2n. Okay, so let's try it for 1. n equals 1. We're going to get 3 plus 2 equals 5. Okay, so now let's try it for n equals 2. Okay, we're going to get, I'm sorry. Yes, we're going to get 3 times 2 plus 2, which is 8. Okay, it's not what we wanted, but it's fairly close. Okay, we can do something here. When n equals 1, it doesn't matter if we multiply it, right? It's not going to change anything in here. But when n equals 2, we'll multiply this one more time and we'll get 16 here. Okay, so let's try n equals 3 with this new pattern. We're going to get 3 times 3 plus 2 times 3. So in here we'll get 11 times 3, and we'll get 33. Okay, so that is desirable, that's what we want, and if you keep trying it, you'll see that it does work. Coming up with answers for ones like these takes quite a bit of practice, and there are several methods, and I would look into them. If this really bothers you, look into this if you really feel that you need extra work on it, okay? Okay, question 19 wants us to find the sum to infinity of this sequence, and the sequence, you can tell, is going to repeat itself. It's just going to be 9/10 to the first power squared, cubed, and then to the fourth, and so on and so forth. And so there is a little trick when doing a problem like this. So these fractions over here, because they're continuous but doing this, it's going to follow a certain pattern, and what you're going to end up finding is that certain numbers start to become negligible, and you can just use this equation instead. I've already written it out over here. It's a over 1 minus r. Okay, so you're going to take, where a is this starting number, 1, and the r is the repetitive number over here. Okay, so we're going to take 1 over 1 minus 9/10. Okay, and that's the same thing as saying 1 over 10 minus 9/10, which is equal to 1 over 10, which is the same as saying 10. Okay, and there's your answer. So remember this little trick when you see sequences that are like this. Question 20 looks like this, and it also says, so if m, it has this little dot, n equals n minus n plus 2, then find the value of this. And at first you're all confused, what is this funny notation? Basically they're telling you a rule, and you just need to follow their rule, okay? So this m dot n thing means to do this, okay? And here is your m, right here, and here's your n. And we're now going to follow this rule. So if the rule is n minus m plus 2, we're going to say n, which is -5, minus m, which is 3, plus 2. Okay, we're going to just continue simplifying, and we get -5 minus 5 is -10. And that's your answer for number 20. Here we have question 21, and it has some notation going on here. So it instead of this @ symbol, it has a circle with an X in it. Don't worry about it. It's just it's showing us a rule, okay, because it's a binary set of numbers, okay, and it says for all integers m and n, and it says find the inverse of -5. under this operation if the identity element is 0. Okay. Quite simply, since it has the identity element of 0, we can work with the inverse in the way that we're used to working with it. And so basically we're just going to take the inverse of negative 5 is going to be the negative of negative 5, which is going to be positive 5. And that is your answer. So here we have question 22. And then it wants us to find the absolute value of Q. Okay, so when you see this format like this, you're basically just going to cross multiply, sort of, but not really. You're not multiplying actually at all. Sorry to confuse you. You go diagonal, and so you do 9 plus 4 parentheses minus, okay, the quantity negative 7 plus negative 2. Okay, so let's simplify. We're going to get 13 minus negative 9. And then we're going to add these, and we're going to get positive 22. Because I did an intermediate step here. I did 13 plus 9, right? And then we get positive 22. And the absolute value of positive 22 is just 22. So that's your answer. Alright, so question 23 gives us this, and it wants us to evaluate x. Okay, and so what we're going to do, this time we cross multiply. Okay, so we're going to get x plus, x plus 3 times x minus 1 minus x plus 2 times x plus 1. Okay, so we're just going to multiply these out. So we're going to get x squared minus x plus 3x minus 3 minus, x squared plus x plus 2x plus 2. Okay, so let's keep simplifying. We're going to get x squared minus plus 2x minus 3 and minus x squared, we're going to get, so this together is 3x, and we're going to get negative 3x minus 2. Okay, so here we have this. These two are going to cancel. Okay, and then 2x minus 3x is negative x, and negative 3 minus 2 is negative 5. Okay, and we're going to set it equal to negative 10. That's what they told us over here. And so then we're just going to say negative x is equal to, we're going to add 5 to both sides. Okay, so we're going to get negative 5, and x is equal to 5. Okay, that's your answer. Here we have question 26, and it shows us this drawing. It says that, it tells us that TS is parallel to XY, and that xy is equal to ty, okay, and that's also shown by the arrows and the little lines in the picture. Alright, so what's important to note here is that since xy and xt are the same length, that makes triangle xty an isosceles triangle. So that means that, so here's my representation. So here's t, x, and y. Okay, so if this is 45 degrees, that means that this angle is also 45 degrees. Okay, 47. Okay, so these are both 47 degrees. Okay, and so a triangle has 180 degrees. So I'm going to add up the 47. Okay, so 14, 4, 1, 94. Okay, and then I'm going to take 180 minus 94. Okay, and this becomes 7, 10, 6. Okay, so then we get, I overdid myself. Okay, 86 there. Okay, so we have 86 degrees right here. Okay, so that's this angle right here. This is 86 degrees. Now another important thing to note is that since TS and XY, TS and XZ are parallel to one another, or I should say YZ, these are transversals, okay? So right here we know that this angle is 86, all right? And so since there's a transversal here, we want n plus 34 to equal 86, okay? Because this angle up here is 34, and this full angle is equal to all of this, okay? So n plus 34 is equal to 86. So we're just going to subtract 34. N is equal to 52. I hope I did that math right there. That's, yep. N is equal to 52 degrees. Okay, so 27 asks us to find the area of a triangle, and it tells us a few things about the triangle. It lets us know that it's isosceles and that the hypotenuse is 2 centimeters and that it's a right angle triangle, okay? So that's very helpful. I'm gonna start over there. Okay, so here is a triangle. It's a right angle triangle. These two are the same length, and the hypotenuse is 2 centimeters. Okay, so that means that since these are the same length, we can give it the same variable. And we know from the Pythagorean theorem that a squared plus b squared equals c squared. So that means that x squared plus x squared equals 2 squared, or 2x squared is equal to 4, which means x squared is equal to 2, which means that x is equal to the square root of 2, okay? And now we use the area, okay? So we're going to say, we know that area of a triangle is 1/2 times the base times the height. So we're going to say 1/2 times the square root of 2, and I'm going to leave it as root 2 over 1, so that makes it easier when we're solving, okay? And this is again the square root of 2 over 1, okay? Because one of these is going to be your base, one of these is going to be your height, all right? So then we're just going to multiply straight out, and the square root of 2 times the square root of 2 is just 2, times 1 is still 2, and 2 times 1 is 2, so this is 1 centimeter squared is your area. Question 28 tells us about a circle. The radius of the circle is 13 centimeters, excuse me, and then it says that from the center of the circle, 5 centimeters down, a chord, okay, we're going to say this is 5 centimeters, a chord is drawn, okay, so this is the chord that's drawn, 5 centimeters down, and it wants us to know how long is this chord, okay, so let's start just by solving for this right here, okay, so this is a triangle, this is 5, 13, and x, okay, and you know that 13 squared is going to be equal to 5 squared plus x squared, and 13 squared is 169, this is 25, and this is x squared again, so 169 minus 25 is going to be 144 equals x squared, which means that x is going to be 12, okay, so we know x, and then since this was drawn from the center down, the distance from here to here is the same as the distance from here to here. So that means that this is also x, which means that the entire distance of this chord is 2x. Since we know that x is 12, then we're just going to say 2 times 12, and our answer is 24. Here's question 29. It asks us for the radius of a sphere with a surface area of 154 centimeters squared. So the equation for the surface area of a sphere is 4 pi r squared. Okay, and so what we want to do is solve for r. So this is equal to our surface area, right? Surface area. So that means that 4 pi r squared is equal to 154. So then r squared is equal to 154 divided by 4 pi, okay, and then r is equal to the square root of 154 divided by 4 pi, okay. Pi can also be represented by 22 over 7, okay, that's an appropriate fraction to use for pi. So we're going to have 154, oops, there you go, over, so this is 4 over 1 times 22 times, or sorry, 22 over 7. So we're going to continue simplifying. This is 154, and this is 88 over 7. And then, so this is the same as saying r equals the square root of 154 over 1 times 7 over 88. Okay? And then, so just bear with me here. So what we're going to get now is we're going to say, let's see here, we're going to do, oh, okay, one moment please. Alrighty, sorry about that. So now we're going to keep going. So we're going to try to simplify this as best as we can. So 154 times 7, this is 7 times 4 is 28. We're going to bring up the 2. This is 35, 37. Bring up the 3, and this is 10. Okay, and then it's going to be over, so it's going to be 1078 over 88. Okay, so we're just going to try to simplify this into something that we can possibly understand as best we can. So let's see, what can we divide both of these numbers by? Okay, I'm just going to try, oh, let's see here, 1078, and so I'm hoping to get a number that a perfect square, so that I can get rid of the square root. So let's see here, 5, 22, 5, 1110, so 4, okay, which is 88, and then, oh, what did I get here, it's 9, and this is 0. Right, so this is, and then 9, right? 22 times 9, and 18, 1, 18, 19, 19. Oh, I hope I'm doing my math right. And then I go on, and I do, oh shoot, okay. So yes, this would be 298. Okay, well that's good to know. So we're going to reduce this fraction, and it's going to be r is equal to the square root of 49 over 4, which we can split that up and say the square root of 49 over the square root of 4, which is equal to 7/4. Just kidding, 7 halves. And that's your answer. Question 30 asks us to find the locus of a particle which moves in the first quadrant, so that it is equidistant from the lines x equals 0 and y equals 0, where k is constant. Okay, so what's important to note here is that we are working in the first quadrant. And so when you draw a coordinate plane, let's see here. Okay. Okay. Oh. Okay, so this will be your coordinate plane, where this is x and this is y. This area right here, this is your first quadrant, and then it goes 2, 3, and 4. Okay. So we're going to be working with the first quadrant only. And then it says it wants to know about the two certain lines. So it says the locus of a particle which moves in the first quadrant, so it is equidistant from the lines x equals 0 and y equals 0. So I'm going to draw the line x equals 0. Okay, so for the line x equals 0, that means that no matter what y value you have, x is always equal to 0. Okay, so that's represented by this line right here. For the line y equals 0, that means no matter what x value you have, the y value is always 0. And I think I just did that backwards. But, so whatever y value you have, so if you have x equals 1, 2, or 3, your y is always 0. So this is y is equal to 0, sorry. And then this is x is equal to 0. Okay? And then what it wants to know is the locus of a particle which moves in the first quadrant, and it's equidistant. Okay, so you really just have to look at the picture and imagine to yourself, what would be equidistant from these two lines? Well, that would be right here, sort of like diagonal between the two of them. Okay, so this is the line x equals y. So y equals, you could also just write it as y equals x. So that means that whenever, like, if y is if x is 1, so is y, and vice versa. And so it's pretty easy to see, just visualize it here, that this line would be the locus of the points that would be equidistant from these two lines. Okay, so question 31 says, what is the locus of the midpoint of all chords of length 6 centimeters with a circle of radius 5 centimeters and with center O? So I've drawn us a picture, and so basically what we have to imagine is, so it talks about these chords of length 6 centimeters, and so chords are within a circle, and so here are the chords that I've drawn, and they're all 6 centimeters long. Okay, we're just imagining that they're all 6 centimeters long, and so that makes a square. And then it says that the radius of the circle with center O is 5 centimeters. Okay, so what they want to know is what is, and I'll choose another color for this. What is this length right here? We can figure out the length of this section of this triangle by saying that this is a perpendicular bisector. So this makes a right angle, and that it bisects the 6 centimeter line into 3 centimeters. Okay, so then we know that if we call this x, that 5 squared equals x squared plus 3 squared. So 5 squared minus 3 squared is equal to x squared, and we take the square root of everything. Alright, and then you'll find that x is equal to 4. Okay, and so that would be the locus of the midpoint of all chords. So this would be your answer. Question 32 says, what is the value of p if the gradient of the line joining the points -1, p and p, 4 is 2/3? So essentially what this is asking is, there are 2 points, and we're going to say that they are that's something else. We're going to say that they're on a plane. Okay, So here is x and here is y. And we have the point -1 p, so it's going to be -1 something. Let's just imagine somewhere around here. And then p comma 4. So the point is, you know, it could be here, it could be down there, but the point is there's 2 points, and this is what is the value of p if the gradient of the line joining these 2 points. The gradient of the line joining these 2 points. So here's a line joining the 2 points, and the gradient, sometimes known as the slope, of this line is 2/3. Okay, and so you might know that the slope, or the gradient, is equal to m. It's often referred to as m, and y equals mx plus b. Okay, and so another way to calculate the slope is saying y1 minus y2 over x1 minus x2. Okay, so here we have 2 points, and they are -1 comma p and p comma 4. Okay, so let's find the y value of one of these. Okay, so the y value in p comma 4 is going to be 4. So let's say 4 minus, and then we're looking at the y value for the other one, which is p, over, now we're going to look at the x values. So what's important is that if we chose this point first, we're going to continue to use it first. So here's p minus, and this time it's -1. This is going to be equal to m, which actually they told us it's 2/3. Right? Okay. So now we're just going to solve for p. And so there's a number of different ways you can do this, but essentially you just want to simplify, and I'm going to switch colors because I'm bored of this one. So here we have 4 minus p over p plus 1 is equal to 2/3. I simplified this part. And then I'm going to multiply both sides by 3. So I'm going to say times 3 times 3. Okay? So now we have 3 times 4 minus p over p plus 1 is equal to 2. And then I'm going to distribute my 3. So I'm going to say, I just distributed over the top, so it's going to be 12 minus 3p over p plus 1 is equal to 2. And then I'm going to multiply both sides by p plus 1. Okay, so and then I have 12 minus 3p is equal to 2p plus 2. I distributed the 2 here. Okay. And then I'm going to continue solving. I'm going to say I'm going to add 3p to both sides. I have 12 is equal to 5p plus 2. I'm going to subtract 2. Okay, so now I have 10 is equal to 5p. Now I'll divide by 5, and I'll get that 2 is equal to p. And that's your answer. Okay, so here is question 33. It says, what is the value of r if the distance between 4, 2 and 1, r is 3 units? So I've already outlined some things for you. First, I wrote the distance formula. So its distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And then I wrote the points 4, 2 and 1, r over here, and I labeled x and y of each one. And I said this point up here is going to be x1 and y1, this is going to be x2 and y2. And we're just going to plug everything that we have into our distance formula. So 3 units is going to be our distance. And I started writing this out. Okay, so then that means that 3 is going to be equal to the square root of -3 squared plus, and we can expand this. And so this is the same as saying r minus 2 times r minus 2. And when you have something like this, it's going to be r squared minus 4r plus 4. Okay, so the last term gets squared, the plus 4, and then this part you double this, okay? And you'll start to see the pattern if you do enough of those. Okay, so here we have r squared minus 4r plus 4. Alright? And then, so this might start to seem a little bit confusing. The most we can simplify, it seems it's going to be like 9 plus r squared minus 4r plus 4, and then we could say 3 is equal to the square root of 13 plus r squared minus 4r. But then, you know, what do you do from here? So what you want to do is square both sides. Because remember, as long as you do it to both sides of the equation, it's fine. So now this becomes 9 is equal to 13 plus r squared minus 4r. And then you can subtract 9 from both sides. Okay, so 0 is equal to 4 plus r squared minus 4r. Okay, and then this you can rearrange it, so it's r squared minus 4r plus 4. Okay, and then you can split it up. And so you'll notice this is a lot like what we got before up here. In fact, it's exactly what we got before. So it's going to be r minus 2 times r minus 2. Okay, and so if you were to solve for r here, the r would be equal to 2. So here we have question 34, and it says find the value of sine of 45 and the cosine of 30. And so what's important to note here is that the unit circle comes into play. And so remember that sine on the unit circle is like the y value, and cosine is like the x value. So here, for instance, here we have 45. The sine of 45 would be root 2 over 2. And the cosine of 30 would be it would be root 3 over 2. Okay? Okay. So here we go. The sine of 45 is root 2 over 2. And the cosine of 30 is negative, or excuse me, it's going to be root 3 over 2. And I said negative because we are subtracting. And I tried to draw for you over here what it would be, what it kind of looks like. This part is this, and then this is this over here. Okay, that just helps you visualize things more. I don't know. All right, so what do we have to do? So here's the sine of 45, and we're subtracting the cosine of. So we're here, and then so basically what we want to do is just simplify. And so lucky for us, we have a common denominator here, which means that we can just say that this is root 2 minus root 3 over 2. And that's your answer. Question 35 asks us about a cliff on a bank of a river. And it's 300 meters high, so that's why I've labeled this here. And then it says that the angle of depression of a point on the opposite side of the river is 60 degrees. So here's a point on the opposite side of the river. Okay, and then here's the angle of depression at 60 degrees. So we want to find the width of the river, which is x. And so I've said that it makes a right triangle here, and then up here we're going to say that this is a right angle, which means that this angle inside of the triangle is 30 degrees, because 60 plus 30 is 90. And that also means that this 30 degrees plus this right angle is 120, which leaves us with 60 degrees for this angle. Okay, so that's how I've gotten to where I am so far. Then I've started writing out our trig values. Okay, so sine works with the opposite over the hypotenuse, and so what we're going to do is we're going to take x over the sine of 30 degrees is equal to, and then we're going to have 300 over the sine of 60 degrees. Okay, so this is a ratio, and so the side is on top for both of them, and then the angles, or the sine of the angles in the bottom. Okay, and so the sine of 30 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. And let me just double check that. So the sine of 60, yes, okay. Okay, so we're going to have x over 1/2 is equal to 300 over root 3 over 2. Okay, so this is the same thing as saying x is equal to 150 root 3 over 2. Okay, and I can say that because basically what I did was I said times 1/2 to both sides. Okay, so that's how I got this far. And then what I'm going to say is that this is the same as saying 150 over 1 times 2 over root 3. Okay, and then I'm going to have x is equal to 300 over root 3. And some people might be tempted to leave it there, but actually that's not fully simplified yet. We can't have a square root in the denominator, okay? So what we're going to do is we're going to take 300 over root 3 times root 3 over root 3. Okay, and this is okay because this is essentially 1. And so this way we have 300 times root 3 over 3. And then we simplify just a little bit more. Okay, and we get that x is equal to 100 100 root 3. So here we have question 36, and it's wanting to find the derivative of this equation here, y equals 3 cosine of 4x. Okay, so you'll remember that the derivative of cosine of x is equal to the negative sine of x. Okay, that's because cosine is an odd function. And so we know that much. And then also the cosine of 4x, oops, 4x, it does not equal the negative sine of 4x. It's not that simple. You have to multiply out by 4. So it's going to be the cosine of 4x, the negative 4 sine 4x. Okay, so in this case, what we're going to do is we're going to say we're going to do 3 times 4, and then it's still negative, and we have the sine of 4x, and so we get negative 12 times the sine of 4x as our answer. So here we have question 37, and it wants us to take ds dt when we have s, and it says when t is equal to 4/5. And so this might seem confusing because of the ds dt, and you're like, what am I differentiating? But actually, you're just going to first, let's take s is equal to 2 plus 3t times 5t minus 4. Okay, so we're going to multiply this out. So that means that s is equal to 10t, is the first part, minus 8 plus 15t squared minus 12t. Okay, simplify a little bit more, and we're going to have negative 2t minus 8 plus 15t squared. Okay, and then so I'm going to rearrange it so it's in a form I'm more used to. 15t squared minus 2t minus 8. Okay, so now we're going to take the dt, which is actually fairly simple. So, you know, we just use the power rule for taking the derivative here. So this is going to be 30t, and this is going to say minus 2. Okay? And then they want us to plug in 4/5 for t. So we're going to have 30 over 1 times 4 over 5 minus 2. Okay, so this is going to cancel. This will be 6. 6 times 4 minus 2, 24 minus 2, and our answer is 22 seconds. Alright, so question 38 gives us an equation, x times 4 minus x, and it wants us to know what will make this a maximum. So when you take the derivative, you know that you are essentially making a line with of the slope of the beginning equation and at different point values. Okay, so when you find a maximum of this equation, you are also finding a zero of the derivative, and that's because here is maximum. Okay, so the slope here, all right, that that translates over to having a zero of a derivative. All right, so here's what we're going to do. We're going to take x times 4 minus x. Okay, this is y equals x times 4 minus x. And then we're going to multiply it out. So we're going to have 4x minus x squared. We're going to take the derivative of it. And then so we're going to get negative 2x, right? Because the 2 comes down. And then plus, and this is just 4. Okay, so now we're going to set this equal to 0. Okay, so what I meant is we're finding a root. So negative 2x is equal to negative 4. We're going to divide by negative 2. And x is equal to 2. Alright, so question 39 asks us about a particle, and it wants to know the maximum distance that the particle can cover from the fixed point. Okay, so again, we're going to think of what taking the derivative of a function means in terms of maxes and mins, and so we want to find the minimum distance that it can cover. And so we're going to take the derivative first off of ds. So ds dt is going, and this is cubed actually. So this is going to be 3t squared minus 2t minus 1. Okay, so that's what it's going to equal. And then we're going to set this equal to 0. 3t squared minus 2t minus 1 is equal to 0. Okay, and then to solve for this, it's going to take some work to be able to split this apart. But essentially, you're going to find that it's 3t minus or plus 1 and t minus 1. Excuse me. Now that we've made it this far, we're going to solve for t. So t can be equal to 1, or t can be equal to, here, I'm going to do this part over here, 3t plus 1 equal to 0, 3t is equal to negative 1, t is equal to negative 1/3. So, or t is equal to negative 1/3.
Now given that the equation presented to us is s equal to t cubed minus t squared minus t plus 5, and we have earlier ascertained that t is either 1 or minus 1/3. The question then further goes on to ask to find the minimum distance that the particle travel. To determine the minimum distance, we will use the smaller value of t, which is minus 1/3. So we slot t equal to minus 1/3 into s is equal to t cubed minus t squared minus t plus 5 to get the minimum value. Therefore s is equal to minus 1/3 cubed minus 1/3 squared minus 1/3 plus 5. That is equal to minus 1/27 minus 1/9 plus 1/3 plus 5/1. That will be minus 1 minus 3 plus 9 plus 135 all over 27, 27 being the least common multiple, or LCM, of the above fraction. That will be equal to 144 minus 4 all over 27, which is on 30 over 27. That will be equal to 5.18. And this is approximately 5.2, which is C.
So here we have question 40, and it wants us to integrate secant squared of theta. And so the notation for this, it has this little squiggly, and it has d theta over on the side. Okay, this just means that we need to integrate secant squared of theta with respect to theta, okay? Remember, integrate is sort of like the opposite or the inverse of taking a derivative. It's the same way that division is to multiplication. Okay, so when we say integrate secant squared of theta, we want to think, what do you take the derivative of to get secant squared? So that would be tangent. Okay, so the tangent of theta would give us secant squared if we took the derivative of it. And then we have to say plus some constant k. Okay, and then the reason why we do this is because when you're taking the derivative of tangent theta, you would get secant squared, right? But let's say you took the derivative of tangent of theta plus 2. You would still get secant squared. Okay, and you could take the derivative of tangent plus any number that doesn't have a theta in it, and this would just be, the derivative of a constant is 0, so you would just keep getting secant squared. So to account for all possible answers where you took the derivative of something, you have to say plus some constant. The constant can be 0, or it can be 2, or something else. But anyway, this is your answer. So here we have question 41, and it gives us a chart, and it tells us that the distribution above shows the number of days a group of 260 students were absent from school in a particular term. How many students were absent for at least 4 days in the term? Okay, so we have to look at this, what the question is asking. Okay, so it says at least 4 days. So that means that at the very least 4. Okay, so that could also include 5, and that can also include 6. It does not include 1, 2, or 3 days missed, because that is not at least 4. Okay, so then we also have to take into account that there are these variables here, the x. So notice that we are looking at a group of students of 260. So when we add up all of these numbers here, it should equal 260. Okay, so what we're going to do is add all of these numbers and solve for x, so that we can continue on and figure out how many were gone for the at least 4 days. Okay, so we're going to take here's 2x and x, so it's going to be 3x plus, and 60 and 40 make 100. That's 120. This is 170. I'm going to set equal to 260. Oops, 60. We're going to subtract 170 from both sides, and 3x is going to be equal to 90. Okay, so we're going to divide by 3, and x is equal to 30. Okay, so now we know this much, and then we want to add up these numbers right here. So 40 plus 50 is going to be 90, plus the other 30 is going to be 120. So 120 students were absent for at least 4 days. Alright, so here we have question 42, and it shows us a histogram, and it says the histogram above represents the number of candidates that sat for mathematics examination in school. How many candidates scored more than 50 marks? Okay, so we're going to look at up here, this, 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 and this, and we're going to add all of them. So number of students that scored above the 50 mark, so we're going to look here on. So it's going to be 40 plus, let's see here, where is this at? 25 plus 15 plus 10 plus 5. Okay, and so let's just start adding the numbers here. I'm going to line them up so it's easier for me to add them. And so I'm going to see I have 5, 10, 15 here. And 4 plus 1 is 5. Then 7, 8, 9. Okay, so we have 95 that scored more than the 50 marks. And when you're looking at your options, actually for this one, you're going to see that that's not an option. And so you would just leave it as it is. Question 43 shows us a pie chart, and it says that this chart represents 400 fruits on display in a store, and it wants to know how many are apples. Okay, so first they're giving us the degrees of how much each of these takes up, okay? And remember that a circle has a total of 360 degrees. So if we add these up, we'll get 315 degrees that are being taken up right now. And it's pretty easy to tell that the apple, the degrees of the apple on the pie chart will be 360 minus 315. So that'll be 45. Okay, and it's out of 360 degrees. So this would give you your percentage of how many are apples, okay? And then you can use that and multiply by the 400 fruits total. Sorry, I misspelled the word fruits there. So if you multiply these two numbers, that should give you how many are apples, right? So this can be done actually by a series of simplifications. And if you're not very good at just looking at this and figuring out what it is, so what I did was I said, okay, first I can take this and divide them by 10. So this will be 40 and this will be 36. Alright, and now 45 and 36, well, you can divide both of these by 9. Okay, so 36 divided by 9 is 4, 45 divided by 9 is 5, right? And then you can keep going, and then 4 goes into 40, actually very evenly, 10 times. So now you're left with 5 times 10, and your answer is 50 apples. Hi, so here we have question 44, and it says the cumulative frequency curve above shows the distribution of the scores of 50 students in an examination. Find the 36th percentile score. So you actually don't need very much to solve this problem except for a quick look at the graph and this equation. So this equation helps us to solve percentile scores. So this part of the equation is going to be the percentile score that we want to find, and this is going to be the 36th percentile score, right? And then so this is going to be like a percentage. This is the 36th percentile score we want to find, and n over here is going to be the number of the sets of the data points that we have. So the marks, or the percent score that they can get, goes up to 100. So that is going to be our n, okay? And then m is going to be our 36, because we're looking for a 36th percentile score. So p of m is going to be equal to 36 divided by 100 times 100. These cancel, and we're just left with p of m is equal to 36. And when you get your answer using this equation, the 36 is already, this is a percent right here, 36%, which will be answer C on your options. So here we have question 45, and it says 5, 8, 6, and k occur with frequencies of 3, 2, 4, and 1 respectively, and have a mean of 5.7. Find the value of k. So we have to first think about what it means to find the mean, or the average of something. So that's when you take a set of numbers and you add them up and you divide by how many times they appeared, right? So if I had 2 plus 4 plus 1, I would divide by 3 because 3 numbers appeared, okay? So for this example, we have the numbers 5, 8, 6, and k, and they occur this many times. 5 occurs 3 times, 8 occurs 2 times, 6 occurs 4 times, and k occurs once, okay? And when you divide by the number of times that each number, that all of the numbers together showed up, so what that means is, so if I say 5 occurred 3 times, I mean 5 plus 5 plus 5. And 8 two times is plus 8 plus 8, and so on and so forth with the rest of these. So we count how many times a number showed up. 3 plus 2 is 5, plus 4 is 9, plus 1 is 10. So 10 numbers were there, so we're going to divide by 10, and then that mean is going to be equal to 5.7. And so to solve for k, we're going to first multiply everything by 10 so that we can cancel this, and then we're going to get 57 over here, okay? Because you just move the decimal place one place over. All right, and then so let's start multiplying these. 5 times 3 is 15. 8 times 2 is 16. 6 times 4 is 24, and we have just k. Okay, so now we're going to add. So 15 plus 16 is going to give us 31, plus 24 is going to be 55. Okay, so we have 55 plus k is equal to 57. Subtract the 55, and k is equal to 2. Alright, so question 46 says, what is the mean deviation of x, 2x, x plus 1, and 3x if their mean is 2? So again, we have to think about what it means to find the mean of a set of numbers. So each one of these separated by commas is a number. So here we have 1, 2, 3, 4 numbers in total. Okay, so that's going to come into play later on. So first, let's say x plus 2x plus x plus 1 and plus 3x. And then it's all going to be over 4, because if we're finding the mean, we're going to divide by how many numbers there were. And the mean, they told us already, is 2. So now we're just going to solve for x so that we can find the actual value of each one of these. So we're going to multiply by 4 on both sides. So x plus 2x plus x plus 1 plus 3x is now equal to 8. Alright, so that canceled out the 4. And then now we're just going to combine like terms. So here we have, this is going to be 3x, that's going to be 4x, it's going to be 7x, so 7x plus 1 is equal to 8x, sorry, just 8. And then we're going to subtract 1. 7x is equal to 7, and x is equal to 1. Alright, so plugging that into the values up here, then that means that the numbers that we have are going to be 1, 2, 2, and 3. Okay, so I got that this is x, this is 2x, this is x plus 1, and this is 3x, okay? And we already found out that x is equal to 1. So that's how I got these 4 numbers. Alright, and they want to know, what is the mean deviation? Okay, so mean deviation is exactly what it says. We need to know the deviation from the mean. So they told us that the mean was 2. So we're just going to say, okay, so 1 is not 2, it's 1 less than 2. So it deviated -1 away from 2, okay? And then 2 and 2 are the same number, so this didn't deviate at all. This one didn't deviate at all, but this one did. It deviated by 1. Okay, and then we're going to take the absolute value, because when we're doing the math, these would cancel out and then you would think that it was nothing, but that's not true. So you have to take the absolute value of this, so it's going to be 1, 0, 0, and 1. Okay, so these are your absolute deviations. Okay, and now we're going to take the mean of them. Okay, so we add them up and divide by 4, because there's 4 values, and we get 2 over 4, so it's 1/2, or 0.5. So here we have question 47, and it says, in how many ways can a delegation of 3 be chosen from 5 men and 3 women if at least 1 man and 1 woman must be included? So I've noted that this is a combination problem because the order does not matter and there's no repetition, and that's important for right now. So basically, if you have this set of circumstances, it means that you're going to use this equation, okay? So here we have n factorial over r factorial times n minus r factorial. And n is going to be your total, and r is going to be what you're choosing how much you choose of what you have, okay? So they give us, this is what they say: we're going to have 3 people on our delegation, and we have 5 men and 3 women, okay, and at least 1 man and 1 woman must be included. So what we want to do when we do these type of problems is we want to imagine all possible outcomes, and then do the math for each outcome and then add them up, okay? So if we have, say, let's say we have 1 man and 2 women, okay, so what happens is we're going to take, it looks like this: 5 choose 3 times 3, excuse me, not choose 3, choose 2 times 3 choose 1, okay? So this right here is 5 men total, but we only choose 2 of them. And this right here says there's 3 women total, but we only choose 1, okay? And so when you do the math, you're going to say 5 factorial divided by 2 factorial times 5 minus 2 factorial. Okay, so this is the same thing as saying 5 times 4 times 3 times 2 times 1 over 2 times 1 times 5, sorry, not 5. 5 minus 2 is 3, so we're going to have 3 times 2 times 1, okay? So working this out, these are going to cancel, okay? This is just 1, so it's not relevant at the moment. So 5 times 4 is 20. Sorry, 20 divided by 2, which is 10. So the first part, the 5 choose 2, is 10 times 3 choose 1. Well, just think about it. 3 choose 1. There's only going to be 3 ways that you can do that. But you can also work out the math. You're going to say 3 factorial over, excuse me, not 3. 1 factorial times 3 minus 1, which is 2 factorial. Okay, so you're going to have 3 times 2 times 1 over 2 times 1. These cancel, and you're left with 3. Okay, so this is only part of our answer, though, because now we have to take into account the possibility that the team is made up of 1 man and 2 women. Okay, so this time we're going to say 5 choose, here, I'll write it over here. 5 choose 1, because 5 men choosing 1, times 3 choose 2, because there's 3 total women and we're choosing 2 of them. Okay, so the same idea, you know, if you had 3 and you were choosing 1, there's only 3 ways you could do that. If you have 5 and you're choosing 1, there's only 5 ways you can do that. Okay, and then 3 choose 2, you're going to, when you do the math, let me move this out of the way. Okay, so when you do the math for the 3 choose 2, it's gonna be 3 factorial over 2 factorial times 3 minus 1, excuse me, 3 minus 2, which is 1 factorial. Okay, and you're gonna get 3 times 2 times 1 over 2 times 1. These cancel and you just get 3. Okay, so 5 times 3. So then you're gonna have 30 plus 15, which is 45, and that is your final answer. Okay, so here we have question 48, and it says, in how many ways can 9 people be seated if 3 chairs are available? So I've noted that this time order matters, and so this time we're going to be using the formula for a permutation. Okay, the reason why order matters is because if we have 3 chairs and 9 people, if you have 3 different people, you can set them in different ways, and then you're choosing out of 9, so it's going to be a very big you're going to see it's a very big number. So just working with the numbers that we have, we're going to have 9 people to choose from, and we're only choosing 3 of them, so we're going to take out, what it's going to look like is like this, and I wrote this a little bit wrong. It should look like this. Okay, So basically what we're going to have is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? And on the bottom, I don't know why I didn't fill it in over here, but we're going to have 9 minus 3, which is 6 times 5 times 4 times 3 times 2 times 1, okay? So this is all going to cancel, and we're left with just 9 times 8 times 7. And so now all we have to do is this math. So 9 times 8 is 72, and then times 7, so this is going to be 14, bring up the 1, 504 is our answer. Okay, so here we have question 49, and it says the probability of a student passing any examination is 2/3. If the student takes 3 examinations, what is the probability that he will not pass any of them? So what we have to do here is first figure out what is the probability of the student not passing an examination. Okay, so this is a fraction which is out of a whole, right? So 1 minus 2/3 should give us the other possibility that the student does not pass. So that's 1/3. And then the student is taking 3 examinations and not passing any of them. So what you're going to do is you're going to take 1/3 times 1/3 times 1/3. So this is just 1 over 3 cubed, which is equal to 1 over 27. So here we have question 50, and it gives us a table with some marks and the number of students that achieved each one. So the table above shows the distribution of marks of students in a test. Find the probability of passing the test if the pass mark is 5. So what we're going to do is first we're going to set off the cutoff point. Okay, so the pass mark is 5. So the students passing the test are these ones. Okay, so here we have 4, 5, 2, and 1 student that were able to pass the test. So we're going to add those up. And 4 plus 5 is 9, plus 2 is 11, plus 1 is 12. So 12 passed, okay? Now let's see how many total students we have. So there's 3 plus 4 is 7, plus 1 is 8. And we already added up 12 here, so then there's 20 total, okay? So probability is sort of what you want out of what you have. So we want to know how many passed out of the total. So we're going to say 12 out of 20, and then we're just going to simplify. So 4 goes into both of these. So 12 divided by 4 is 3, and 20 divided by 4 is 5, and we get 3/5.